Hello and welcome to this Magenta Academy video. So a few weeks ago we ran our annual technical event, Magenta Academy Live. We ran it on the 21st of April at the Manufacturing Technology Centre in Coventry. Now we appreciate that everybody could make that particular date, so what we decided to do was put together a video or a few videos showing off all of the capabilities that we demonstrated during that day, just to make sure that nobody missed out on anything that they may have wanted to see. So, for those of you that haven't heard my voice before, my name is Joseph Hall. I'm a technical consultant here at Magenta Solutions. Today, in this particular video, I'm going to be taking you through sketching enhancements and part modelling enhancements that have been made in Inventor 2016. So we'll start off with sketching enhancements. There's a handful of sketching enhancements that we can run through in a really quick demonstration to show you those. So in 2016, Autodesk have added the functionality to maintain constraint visibility. So there's a show hide constraint within Inventor, F8 and F9 for those of us familiar with the keyboard shortcut. And what they've done in 2016 is essentially, if you show constraints on a model whilst you're sketching, if you leave that sketch and then you come back to that sketch later on, those constraints are still visible unless you manually turn them off at some point in between. We've also got the ability to turn sketch dimensions on and off in the View option or Object Visibility drop-down list that's available on the View tab on the very left-hand side. So they've added that functionality in as well. A bit difficult to show you this through a picture, essentially, show and hide, but those are the constraints we're talking about. So in a moment I'm going to demonstrate opening up a sketch. You'll see all the constraints. I'll do something on the sketch, leave the sketch, and then when I go back to it later on, those constraints are still visible because we can maintain the link or maintain the visibility of them on. And there is the sketch dimensions option in the Object Visibility on the View tab at the bottom of the list. We also have the ability to identify a sketch plane in 2016. So there is a right click option that enables you to select a sketch, right click, and it's actually called Show Input. And what Show Input will do is it will then highlight to you the plane or the surface that was selected for you to be able to create that particular sketch. So this is a really useful technique just for you to help you understand the way that a model's been created and what might happen if you're changing and editing a model, or understand why something is happening when you're working with a model. And for those of us that are familiar with AutoCAD, Autodesk have had plenty of snaps, object snaps as they're called, within AutoCAD for a number of years now. They've included some of those object snaps within Inventor 2016. So whilst you're sketching, you can now right click and you can see those object snaps. So if I'm sketching something, as I start at Line Tool for example, I can right click, go to Point Snaps, and that is the list of available point snaps that you will see: endpoint, midpoint, intersection, apparent intersection, center, quadrant, tangent, and mid of 2 points. So, let's have a quick demonstration of the sketching enhancements. So, we're going to run you through showing and hiding the constraints and how that stays on, sketch dimension visibility, and new point snaps commands. So in Inventor, let's have a quick look. Let's go into the vault system, and let's open up from draft tool. Oh, sorry, not the wrong one. Didn't want to open that. You're going to see this file in a moment, so I'll leave it open anyway. We're going to go back and we're going to have a quick look on the home screen, and we're going to have a quick look at sketching. Get the right file, lovely. So, here's my file I've just opened up. So the first thing that we're going to do in this instance is we're going to sketch on this particular face. So if I was to go in, we've already got a sketch, we can actually edit that sketch and have a look at it. I can use the offset tool, really quickly offset a loop around there, about 5 mil, something like that. So now we can see, if I turn all the constraints on, those are all the constraints that are persistent on that model. So we've got lots of parallel constraints on here. I'm also going to apply, while I'm in here, a particular point at the center of these 2 points. So I'm going to use point snaps, mid of 2 points, that's point 1, that's point 2, and it will place it down. I can repeat that, point snaps, mid of 2 points, that's point 1, that's point 2, and it places my point in. So when I'm finished, I can use that maybe for a hole and create a few holes that go through all on this sketch. I've just left that sketch. So if I wanted to see, or I'll show you first of all the option for, if I turn a sketch on, you can see that we've turned a sketch on here, we can see there is a circle with the visibility of the dimension and the constraint. If we go to View, under Object Visibility, we can turn that sketch dimension on or off independently of having the sketch on or off. So obviously if I turn the sketch off, the dimension is not going to be visible because it's part of the sketch, but we can still turn that on and off individually. Let's have a quick look back into this sketch while we're here. So I can right click and edit the sketch, and as you can see, as soon as I go back into editing sketch, all of the constraints appear. I haven't got to remember to press F8 to turn them all on again. Inventor just remembers that when I left the sketch, I left it with all the constraints turned on, so therefore all the constraints are turned on. Final one to show in here is the show input command. So the show input command is quite a useful one. As I say, if you're either interrogating a model or you're working on a model and you need to just necessarily understand what's been done to the model whilst you may have been away, or just have a look and see what's going on. So if I want to see, as soon as we look at this model, you might assume that this particular flange that was created on here was added as a result of the revolve. You can see, you can kind of get a good indication from the model tree down here. If I select the extrusion that was used for it, I can right click on the sketch and I can show input. Now what show input does is it then highlights to me the sketch plane that was used or selected for me to start sketching. So in this instance, you can see that the bottom of this plane here was used as the original sketching face for this piece of geometry. So this is maybe a classic example of where this could be really useful for you to just get a good indication of how something's going to work. So we'll close that down. I'll leave you with the image of the draft model on screen, because we are going to talk about that in just a second. So that's the sketching enhancements, a handful of them already added to the sort of vast capability we already had inside Sketcher. Now I want to take you through the part modelling enhancements. So one of the things that Autodesk have tried to do with the part modelling enhancements for 2016 is integrate the parametric world with direct editing and freeform. So direct editing and freeform were added in 2015 as dynamic ways of creating geometry and editing geometry with an Inventor. Direct editing, those of you that don't know, lets you modify and manipulate imported CAD data. So I can import something into Inventor. Inventor won't recognise it. I will just literally see a base import in my model browser. I can select the geometry and modify that. Freeform, uptake on Freeform wasn't as much as potentially there could have been. Freeform is essentially like having, it's T-splines technology, so it's like having, I always describe it as a digital plasticine on screen. You can pick points and faces and edges and vertices and just push and pull till you get the shape that you want. There's been a vast increase in freeform capability for 2016. We're going to talk about direct editing, but we'll focus our attention first of all on parametric, because that's the environment that most people will be aware of and use on a regular basis. First enhancements, nice and straightforward. Autodesk Inventors had the ability of multi-body part models for quite a while. Multi-body part files and their manipulation has been improved in terms of being able to now mirror and pattern multi-body parts within a single part file. Autodesk have also improved the draft tool for 2016. So the draft, they've added functionality to the split line or parting line draft that enables us to move or fix the parting line. In conjunction with moving or fixing the parting line, they've also added the ability to fix an edge and determine where that draft angle is measured from. So just to give you an idea of this, because sometimes it's a little bit difficult to get around in your head what's going on the left hand side of those two images is a previous version of software, 2015, and the features highlighted in the tree are the workaround required in order to just create a 3-degree parting line being moved out by 3 degrees. So applying a draft to those surfaces with a parting line moving out 3 degrees. There's something like in the region of about 15 features there, plenty of lofts and extrusions and splits, in order just to get what is in fact a relatively simple function. 2016, Autodesk have improved their draft capability to enable us to now just create that in a single draft feature. So you've already seen the model, let's have a quick look. So if we start off with the model to start with, we're going to go into draft, and I'm going to use my parting line draft tool, and the first thing I'm going to specify is my pull direction is going to be the same as the plane that we've got here. My parting tool I'm going to use is going to be that curve, and the face that I want to draft is that particular face there. So if I was to spin this round and just use the arrows to show you what I'm going to get, this is what we had. So this is not new capability to Inventor, this was what was available previous versions of the software. So if I go to the left view, just to show you again, we are drafting around that particular line. 2016 they introduced in the draft tool two dialog box, two little options, so a fixed parting line and a move parting line. If I choose to move the parting line, now what happens as I draft, you can see it's actually physically moving the parting line that I'm using for this draft. So if I was to spin around, as you can see now, just so you can see and have a look, that's actually what's happening. I'm moving that parting line, physically moving the parting line. Maybe a bit too far away, it gets a bit drastic, but I start to get some really complex resulted geometry based upon what I'm doing. You probably wouldn't have a 30-degree draft on that, I know, but I'm just sort of highlighting to you what it will do. So as well as this, they added the capability, let's kick it out a little bit more than that. They also added the capability, let's go back into a left view, to define where this is measured from. So at the moment it's set to angle for both. Let's just auto fade that out of the way. At the moment it's set for angle for both. I could set an angle for the top or just an angle for the bottom, and that will determine the results that I get. If I go back to an angle for the top, this is where it gets even more powerful now. So we've got a draft capability, and you can see what that result that's giving me. It's giving me a fairly drastic draft on that geometry. But it might be, you can see the little silhouette, if you like, in the background of the edge as it was before I made these manipulations. So the edge in the background I might want to maintain. So now we have in the box the ability to fix a edge. So if I hover over, I can fix that static edge at the top and then manipulate the bottom. I could even fix the bottom edge if I wanted to, which now enables me to fix both of those edges but still apply the draft that I want to the geometry. So this is really added and enhanced the ability that we have within the draft tool for Autodesk Inventor 2016. Nice and straightforward. Create some really useful results from that. So I can OK that now, make sure I've checked it out the system so we can modify, but we can see the results that we can get from that, and really slick draft tool capability that we've got now. So that's your draft enhancement. Let's have a quick look back at the slides. Other part modelling enhancements that have been added to silhouette curve and the ruled surface. So ruled surface is a new command that I'm going to show you in a moment. It's added to the functionality, or the surfacing functionality within Inventor. So Autodesk obviously have Alias as part of the design suite that will help you to create freeform shapes, and Inventor has some surfacing capabilities that you can utilise to create geometry that's a little bit more complex or difficult to create with solid methods. Ruled surface is added to that capability. I'm going to show you that in a demonstration in a second. So I mentioned at the start there's three areas. Parametric we've run through, direct editing I'm going to mention in a moment, but freeform is an area of the software they have greatly improved in Inventor 2016. So there's now support in freeform for open sheets. So by open sheets we're referring to things like, well, a flat plane. This gives freeform much more capability to create dynamic forms, because it no longer is trying to calculate a closed volume. Now it can create an open sheet. We've got a match and a rematch command, and I've actually enhanced the freeform capability so much that freeform has actually been given its own dedicated freeform ribbon with all the commands in there. So when you're in freeform now, you now get a full ribbon across the top of the screen to work with of all of the commands. There's lots of enhancements that have been added to freeform. Haven't got time to run through all of them with you. I am going to show you a snippet of some of them in a demonstration in a moment. Added functions include, I mentioned open sheet, the ability to convert an existing face into freeform. So you can take an existing face of a model, convert it into a freeform shape, and then manipulate it. You can delete faces, you can add patches, and you can also flatten out geometry. So there's an example of taking an existing top face of a solid model, converting it to freeform so we can manipulate it, and then utilising the flatten tools to be able to flatten that out if it's not already flat in this case. Other additions that we've added into part modelling or freeform, the ability to weld vertices. So any of those points that you can see on the geometry, you can now select multiple points and weld them together to, again, create more dynamic forms. There is a freeform thicken command. So thicken traditionally outside of freeform. Obviously now we have the ability to create an open sheet, which is in effect a surface. We also have the ability to thicken that whilst still inside the freeform functionality. We've also added the soft modification tools to enable you to make subtle small changes to geometry as opposed to larger changes. So that's enough talking about freeform. Let's have an actual go and show you some freeform geometry. So again, we'll open something up, we'll drop into the right folder. That always helps when you're working on files. And I'm going to open up a little drill model that we've got here. So you can probably see in the background of this image there, in the background of this file rather, there is an image. So it's always a good idea to have an image when you're working with freeform. It just gives you a little bit more of a guide to work with. And as you can see, or as you're going to see in a moment, we've also got some sketched curves that we're going to utilise. So we'll open the file up, and you can see that we've already got some predefined surfaces that we're going to utilise to create. Now this surface is created from a loft, so it's a parametric surface. You can see there's the dimension on the end. We've got a dimension at the start, we've got a length between those 2 points as well. We've got a diameter, so we've actually got a parametrically defined shape that we're actually going to take and we're going to freeform this now. So show you the convert tool to start with. We're going to convert that existing face into freeform. We're then going to define how many faces we want in each direction, so I might want 6 in either direction. I can also define spacing as either length or curvature, so I can have, as uniform or curvature. So uniform is going to give me much more T-splines to play with. I'm going to leave it as uniform to start with. And now we're working in freeform. You may have spotted the ribbon across the top of the screen. I'm actually going to apply symmetry between those two surfaces because everything that I want to do, I want to be symmetrical. And I'm now going to select a couple of faces to work with. Now again, selection techniques within freeform have been enhanced. So if I select one face, I can hold the shift key down and double click, and it will then select a full range or all of the faces in between those two. So it makes it easy for you to select multiple faces. We're then going to edit the form. We had the extrude capability within 2015, they just added it into the dialog box for 2016. And then we're going to move those faces in by about 4.25, something like that, to create a geometry. Just spin that around really quick. You can see that's on both sides, so that's lovely. That's exactly what we wanted to do. That's all I'm actually going to do for that top piece. So I'm going to finish the freeform geometry to come out of freeform, and I'm now going to find that top surface and just turn it off so you can see we still have got our opaque surface, our translucent surface that you can see at the top of the screen. So I've created that particular surface from freeform. So again, that's a support for open sheet. That's an example of it right there. We're going to do another one here. We're going to create a cylinder at the top. So just like we've got box, there's the plane. All the others we had in 2015. So we're going to create a cylinder. Now for this cylinder, what we're actually going to do is we're going to create a cylinder that sits on that sketch, or on the same plane as that sketch, and is centered about that center point there. We're also going to define the radius for this as whatever this diameter is divided by 2. That's the same value then. Again, we've got it parametrically controlled. We can define the height as a specific value, and for this I'm going to uncap that surface. You can see how that modifies the surfaces that we've got. 4 faces round is okay, but I would like 6 faces up, and we can then apply some symmetry. So we've got symmetry that we can apply down the center to create the geometry that we want. We manipulate that into the front plane. Always a good idea to use your view cube views when you're creating things with freeform. Just helps you to visualize and make those changes in the correct direction. Again, edit form. I'm going to pick the entire body this time and just pick that and rotate it by about 15 degrees is fine with me. So we've got the geometry created. I mentioned edge, the match edge command that we've got within freeform. So we can use match edge. Again, selection techniques. If I double click on the edges, that'll then give me the ability to pick a full range of those edges. I can then target an existing edge and move one for the other. I can then repeat that, so spacebar to repeat that edge, continue to pick that one. It's really quickly. I've now got a freeform geometry that's open sheet, that's controlled by parametric curves. So that's a parametric spline that's been sketched in the background. I'm now, rather than leave the freeform geometry, I'm actually going to continue by converting the bottom face. So we'll convert the bottom face. I just want one face, and we're going to have 8 faces. Now I need to make sure we've got 8 faces because this one's got 4 and we're going to connect onto that one, so we need to have a multiple of it so it gets 2 to 2. We can OK that, and then with that in place again we'll do some symmetry, so we'll do symmetry between these 2 faces. That's nice. I'm actually going to turn the image off just so you can see a little bit clearer, that's a bit better. And now I'm going to take the geometry that we've got and I can edit form, pick that point and drag that in a little bit to give me what I need. Then I can bridge, so we've got a bridge command. Again, double click to select a loop, really easy. Start point to start point, make sure those are in the same place, and then when you click OK, I'll then create a blend between those two. It's really easy to create this type of geometry now. Again, finish freeform. I'm just going to find that surface and hide it, so make sure you can see what I've actually just created. There you go, it's a little bit clearer now. So I mentioned to you in the slides the ruled surface command. So the ruled surface command sits here and enables me to select a set of edges and create either a tangent, a normal, a tangent, or a swept surface. So I'm going to use a tangent. I'm going to specify how far, so I'm going to say 20 mil, and click OK. That will then create a tangent surface extended from the geometry that we've already got. We'll finish it off by patching the bottom, just to create a full patch, and we can stitch the bottom surfaces together, so we might stitch 1, 2, 3 all together to create our geometry, and we'll finalise the model by sculpting between these geometries to give me a complete solid. Okay. If I were to do an analysis on this, if I just go to view and do an analysis on that particular surface and that surface, so we could do an analysis on these 2 surfaces, we'll be able to see how that works. We've got cross-section analysis on there at the moment. If I was to analyse these surfaces, you will see they are continually flowing surfaces, but they're all controlled by parametric curves. That's the main thing to focus on here, is that is a parametric curve. If I change that curve, I can locate the freeform geometry, I can go in and rematch that to the edge. So although we're creating fairly organic shapes, it's organic shapes that's controlled. And this is what we mean when we talk about parametric, integrating with freeform, also integrating with direct editing. So that's a demonstration of some of the freeform capabilities within Inventor 2016. I said I'd mention direct editing, so for 2016 direct editing has been improved by the addition of a scale command. Those of us that weren't aware of direct editing in previous versions of the software, direct editing gave us the ability to modify the geometry of imported CAD files. So if you import a CAD file, you just get a single item at the top of your tree. Direct editing lets you manipulate that and modify it. The ability to scale that geometry has been added for 2016, so in 2015 versions we had move, size, rotate and delete. 2016 sees the introduction of the scale tool. Scale lets me scale something as a uniform scale or as a non-uniform scale in an X, Y or Z direction. One of the functions that we think we should mention all the time when we talk about direct editing is the ability that it gives us to create parametric relationships between dumb geometry. So by dumb geometry I mean something we've imported in from a different CAD system. It's coming to Inventor, it's just a lump of geometry, you can't do anything with it. By specifying surfaces and edges and almost taking measurements with direct editing, everything you do in direct editing is recorded as a parameter within Inventor. So that is in effect creating a parametric value that we can change that will modify the geometry that we want to work with. So direct editing really opens up a world of possibilities for us to work with. So that's all we've got time for in this particular video. We will be running further videos to take you through some of the assembly enhancements and sheet metal functionality, so please, if you're interested in that, make a note and make sure you get up to speed with those videos.